In the 1st century, a Greek military physician named Dioscorides sat down and wrote one of the most important medical texts in human history. His book catalogued over 600 plants and their medicinal uses, and soldiers, healers, and pharmacists would rely on it for the next 1,500 years. Among all those hundreds of entries, Dioscorides made a note about a spiky, purple-flowered weed with white streaks running through its leaves. He wrote that it was useful for treating problems related to bile and the liver. That weed was Silymarin. You probably know it as milk thistle. And 2,000 years after Dioscorides scribbled that entry, doctors in modern emergency rooms are injecting a compound extracted from the same plant into patients who are hours away from total liver failure. At least, that's what the clinical data suggests. But the journey from ancient Greek field notes to a 21st century foredrip is stranger, messier, and more contested than almost anyone realizes. So how did a roadside weed that most people walk past without a second glance end up at the center of a 2,000-year medical debate? This story doesn't start with the science. It starts with a myth. According to Christian legend, the white veins running through milk thistle's dark green leaves came from drops of the Virgin Mary's milk falling onto the plant as she nursed the infant Jesus. That's where the milk in milk thistle comes from, and it's why the plant's Latin name includes Marianum, a reference to Mary herself. Whether you buy the legend or not, the name stuck, and it gave the plant a kind of sacred status across medieval Europe that kept it from being dismissed as just another roadside weed. Long before the Christian legend, though, ancient Mediterranean cultures were already paying attention. Pliny the Elder, the Roman naturalist who died during the eruption of Mount Vesuvius in 79 AD, wrote about the plant's juice being useful for carrying off bile. Theophrastus, the Greek philosopher who studied under Aristotle, referenced similar thistles in his botanical writings 300 years before that. The ancient world didn't have liver function tests or clinical trials. They had observation, repetition, and pattern recognition. And the pattern they kept noticing was that people who consumed preparations made from this particular thistle seemed to recover from ailments that centered on one specific organ. The liver. I mean, think about that for a second. Physicians, separated by centuries, writing in different languages, living in different empires, kept arriving at the same conclusion about the same plant. That's either a remarkable coincidence or these ancient doctors were onto something real. By the medieval period, milk thistle had graduated from field observations to formal herbal medicine. Monastery gardens across Europe cultivated the plant deliberately, alongside lavender, chamomile, and dozens of other medicinal herbs. Monks who maintained these gardens weren't just growing flowers. They were running the closest thing the medieval world had to pharmacies, and milk thistle earned a permanent spot in the rotation. The plant was versatile too. Young leaves were eaten as salad greens after the spines were trimmed off. The flower heads were boiled and eaten like artichokes. The roasted seeds were brewed into a coffee substitute. Milk thistle wasn't just medicine, it was dinner. And that dual identity as both food and remedy helped the plant survive in European consciousness, even as more exotic imports from Asia and the Americas started crowding the herbal shelves. Then came Nicholas Culpeper. In 1653, the English physician and herbalist published The English Physician, a book that would become one of the most widely read medical references in the English-speaking world for over a century. Culpeper was a controversial figure. He translated Latin medical texts into English so common people could access them, which infuriated the College of Physicians in London, who wanted to keep that knowledge locked behind professional gates. In his writings, Culpeper specifically recommended milk thistle for opening the obstructions of the liver and spleen and for treating jaundice. He wasn't guessing. He was drawing on the same thread of observational medicine that stretched all the way back to Dioscorides. And somehow, it gets worse for the skeptics. Because Culpeper wasn't alone. German herbalists documented the same uses. French pharmacopoeias included it. Italian folk medicine prescribed it for liver complaints well into the 19th century. Across different countries, different languages, and different medical traditions, the consensus held. Milk thistle was a liver plant. This is where the story takes a turn that nobody expected. Because just as milk thistle's reputation should have been cemented by centuries of consistent use, the entire foundation of herbal medicine started crumbling. The 19th and early 20th centuries brought the rise of modern pharmacology. Aspirin was synthesized in 1897. Penicillin was discovered in 1928. Suddenly, the future of medicine looked like laboratories and chemical compounds, not monastery gardens and dried flower heads. Milk thistle got swept out with the rest of the old herbal traditions. Serious physicians dismissed it. Medical schools stopped teaching about it. Pharmaceutical companies had zero interest in a weed that grew wild on roadsides and couldn't be patented. By the middle of the 20th century, suggesting milk thistle as a treatment for anything would get you laughed out of most Western hospitals. 2,000 years of observational medicine, tossed aside in a few decades. And if that were the only problem, milk thistle might have stayed buried forever. But then people started dying from mushrooms. Specifically, from one mushroom, Amanita phalloides, the death cap. The death cap mushroom is, by most toxicological estimates, responsible for more than 90% of fatal mushroom poisonings worldwide. It looks almost exactly like several edible mushroom species, which is exactly why it's so deadly. People pick it, cook it, eat it, and feel perfectly fine for the first 6 to 12 hours. Then, the amatoxins kick in. Here's what amatoxins do. They enter your liver cells and shut down a critical enzyme called RNA polymerase II. Without that enzyme, your liver cells can't produce the proteins they need to survive. The cells start dying. Your liver, the organ responsible for filtering every toxin out of your blood, begins destroying itself. By the time most patients reach a hospital, the damage is already catastrophic. Without treatment, death cap poisoning kills somewhere between 50 and 90% of victims, depending on the amount consumed. And for decades, doctors had almost nothing to offer. Supportive care, fluids, hope. This was the state of things in Europe through the 1950s and 60s. Death cap poisonings were a recurring nightmare, especially in countries like Germany, France, and Italy, where foraging for wild mushrooms was part of the culture. Every autumn brought a new wave of cases, and every autumn, doctors watched patients die because there was no reliable antidote. Enter a group of German researchers at the University of Munich. In 1968, a team led by chemists Hans Hikino and Herbert Wagner managed to isolate and characterize the active compounds in milk thistle seeds. They identified a complex of flavonolignans that they collectively named Silymarin. The most potent individual compound within that complex was called silibinin. This decision seemed small at the time. It wasn't. Because once researchers had a purified, measurable compound, they could actually test what the ancient physicians had been claiming for 2 millennia. And the results were striking. In laboratory studies, silibinin appeared to do exactly what folk medicine had always suggested. It protected liver cells. Specifically, it seemed to block the uptake of amatoxins into liver cells, stimulate protein synthesis, and act as a potent antioxidant within liver tissue. The real question is what happened behind closed doors when those early results started circulating. Because moving from a lab finding to an approved medical treatment is a long, ugly, political process. And Silymarin didn't have a pharmaceutical company backing it. There was no billion-dollar development pipeline. There was a group of German researchers, a weed, and a bunch of dying mushroom patients. Throughout the 1970s and 80s, European physicians began using intravenous silibinin as an emergency treatment for death cap poisoning. The protocol was informal at first. Doctors in Germany, Austria, and Italy who were aware of the research would administer it when patients showed up with confirmed Amanita phalloides ingestion. The outcomes were encouraging. Survival rates in treated patients appeared to improve significantly compared to historical cases that received only supportive care. One of the most cited datasets comes from a retrospective analysis of over 1,500 cases of death cap poisoning treated with silibinin across European hospitals. The mortality rate in the treated group dropped to below 10%. Compare that to the 50 to 90% fatality rate in untreated cases, and the numbers start looking extraordinary. You'd think someone would have said something. Nobody did, at least not in the United States. While European hospitals were quietly integrating Silymarin into their emergency protocols, American medicine largely ignored the compound. The FDA hadn't approved it. It wasn't manufactured by any major pharmaceutical company. It existed in a regulatory gray zone, somewhere between a dietary supplement and an experimental drug, and nobody with institutional power was pushing to change that. That changed in 2007, when a family in Santa Cruz, California, ate wild mushrooms foraged from their yard. The mushrooms were death caps. All 5 family members were hospitalized with severe liver damage. The attending physicians, running out of options, contacted researchers who had been studying Silymarin. Under the FDA's Emergency Investigational New Drug Protocol, they obtained intravenous Silymarin from a European supplier and administered it to the patients. All 5 survived. That case cracked the door open. Over the next several years, more American hospitals began requesting emergency access to intravenous Silymarin for death cap poisoning cases. A clinical trial, partially funded by the National Institutes of Health, was launched to study the drug's effectiveness more formally. The compound that ancient Greek physicians had recommended for liver problems 2,000 years ago was finally getting its shot at modern validation. If you're finding this useful, consider subscribing. We cover stories like this, where history and science collide, every week. The survival of those Santa Cruz patients wasn't just a medical case study. It forced the American medical establishment to confront an uncomfortable question. Had they been ignoring a legitimate treatment for decades simply because it came from a plant instead of a pharmaceutical lab? The answer, predictably, is complicated. Silymarin and Silymarin have now been studied in hundreds of clinical trials worldwide. The results are genuinely mixed, and being honest about that matters. For acute mushroom poisoning, the evidence is strong. Multiple case series and retrospective studies show improved survival rates, and while a perfect randomized controlled trial is nearly impossible to conduct because you can't ethically give dying patients a placebo instead of a potential cure, the accumulated data is compelling enough that most toxicologists now consider Silymarin a standard part of death cap poisoning treatment. For other liver conditions, the picture gets murkier. Studies on milk thistle for alcoholic liver disease, non-alcoholic fatty liver disease, and hepatitis C have produced results that range from modestly positive to inconclusive. Some trials show reduced liver enzyme levels, which suggests less liver damage. Others show no statistically significant benefit compared to placebo. The problem is partly methodological. Many early studies used different preparations, different doses, and different patient populations, making it hard to compare results across trials. Silymarin from one manufacturer isn't necessarily identical to Silymarin from another, because the ratio of individual compounds within the complex can vary. The FDA still classifies milk thistle as a dietary supplement, not a drug. That distinction matters enormously. Supplements don't go through the same rigorous approval process as pharmaceutical drugs. They don't require proof of effectiveness before being sold. And the companies selling milk thistle capsules at health food stores aren't making the same product that gets injected into poisoning victims in emergency rooms. That's the kind of nuance that makes accountants and regulators and patients lose sleep. Meanwhile, the plant itself doesn't care about any of this. Milk thistle continues to grow wild across southern Europe, North Africa, the Middle East, and parts of Asia. It's been introduced to the Americas, Australia, and practically every temperate region on the planet. It thrives in disturbed soil, roadsides, empty lots, and neglected fields. It's technically classified as an invasive weed in several countries. You've probably walked past it 100 times without knowing what it was, and that's one of the strangest parts of this whole story. The same plant that emergency room doctors use to save lives from lethal mushroom poisoning is growing in ditches and abandoned parking lots. Nobody's harvesting it. Nobody's even looking at it. The global milk thistle industry, by contrast, is enormous. Commercial cultivation happens on a large scale in countries like Argentina, Poland, Hungary, Egypt, and China. The seeds are harvested, dried, and processed to extract Silymarin, which is then packaged into capsules, tablets, and tinctures sold in health food stores, pharmacies, and online retailers around the world. Market analysts estimate the global milk thistle supplement market is worth well over $1 billion annually. For a plant that most people couldn't identify in a lineup, that's a staggering amount of commerce. But this wasn't just about supplements and health food stores anymore. The medical research kept expanding. In 2010, researchers at the University of Colorado published a study exploring Silymarin's potential effects on prostate cancer cells. Laboratory findings suggested the compound might inhibit cancer cell growth through multiple pathways, including blocking certain signaling molecules that tumors use to proliferate. Similar laboratory studies have explored potential applications in breast cancer, lung cancer, and skin cancer. Now, a critical caveat. Laboratory studies on cancer cells are not the same as treating cancer in living patients. The gap between "this kills cancer cells in a petri dish" and "this cures cancer in humans" is enormous, and many compounds that look promising in the lab fail completely in clinical trials. Nobody responsible is claiming milk thistle cures cancer, but the fact that researchers at major universities are even investigating these pathways tells you something about how far this plant has traveled from the margins of folk medicine. The liver protection mechanism, though, is where the science is most developed. Researchers now understand several specific ways Silymarin appears to work. It stabilizes liver cell membranes, making them harder for toxins to penetrate. It stimulates ribosomal RNA synthesis, which essentially helps liver cells repair themselves faster. It acts as a free radical scavenger, neutralizing the oxidative stress that damages liver tissue during toxic exposure. And it appears to have anti-inflammatory properties that reduce the immune system's tendency to cause collateral damage during liver injury. If milk thistle had stopped here, this would be a very different story. A niche plant with a niche medical application, known mainly to toxicologists and supplement enthusiasts. Instead, milk thistle kept finding new relevance. When the opioid crisis began devastating communities across North America in the 2010s, some researchers started exploring whether Silymarin could protect the livers of patients on long-term acetaminophen, one of the most common causes of drug-induced liver injury. Acetaminophen overdose, whether intentional or accidental, is the leading cause of acute liver failure in the United States. The standard treatment is N-acetylcysteine, but some researchers have explored whether Silymarin could play a complementary role. Other studies have examined milk thistle's potential in protecting the liver during chemotherapy, when toxic cancer-fighting drugs can cause significant liver damage as a side effect. The idea isn't that milk thistle replaces conventional medicine. It's that a compound from a 2,000-year-old weed might work alongside modern treatments to reduce collateral damage. And then there's the diabetes research. Multiple studies have investigated Silymarin's effects on blood sugar regulation and insulin resistance, with some trials showing modest improvements in glycemic control among type 2 diabetes patients who took Silymarin alongside their standard medications. The mechanism appears related to the compound's anti-inflammatory and antioxidant properties, since chronic inflammation plays a major role in insulin resistance. Again, nobody is calling milk thistle a diabetes cure. But the breadth of ongoing research would have been unthinkable 50 years ago, when the medical establishment had written off the plant entirely. Today, the German Commission E, which is roughly equivalent to an expert advisory panel for herbal medicines, has approved milk thistle extract for the treatment of toxic liver damage and as a supportive therapy for chronic inflammatory liver disease. The World Health Organization lists Silymarin as a supportive treatment for liver conditions. The European Medicines Agency has issued monographs recognizing traditional and established uses of the plant. In the United States, the picture remains more complicated. The FDA hasn't approved Silymarin as a drug for any indication. Clinical trials continue, but the regulatory pathway for plant-derived compounds that can't be patented the way synthetic drugs can remains a fundamental obstacle. Pharmaceutical companies make money by developing proprietary molecules they can patent and sell exclusively for years. Milk thistle's active compounds occur naturally and have been known for decades. There's limited financial incentive to spend hundreds of millions of dollars on the clinical trials needed for full drug approval. So milk thistle exists in a kind of medical purgatory, too well studied to ignore, too poorly standardized to fully embrace, too ancient to patent, too effective in certain situations to dismiss. Walk into any health food store and you'll find dozens of milk thistle products on the shelf. Walk into an American emergency room with death cap poisoning, and the doctor might need to file emergency paperwork to get the same compound through an IV. Walk through any field in southern Europe and the plant is right there, growing wild, its purple flowers blooming above those distinctive white-veined leaves that a Christian legend says came from the Virgin Mary's milk. 2,000 years ago, a Greek physician looked at this plant and said it was good for the liver. 20 centuries of science later, we've confirmed he was right. We've isolated the compounds, mapped the mechanisms, tested them in hospitals, and saved lives with them. And the plant is still growing in ditches, still classified as a weed, still waiting for the rest of the world to catch up to what Dioscorides already knew. Those white-veined leaves that inspired a legend about the Virgin Mary, they're still out there, still growing, still doing exactly what they've always done. Whether anyone notices or not, if this story surprised you, you'll want to see what we cover next. Hit subscribe, and I'll see you in the next one.